Well, hi. I'm trying to do a quick video. I will do a video that show me building the ReAmiga 3000. Um, Maybe some part will be skipped out when I'm doing this, but we'll see how the recording will be. Anyway, as a help, how to build the ReAmiga from bottom to working machine, hopefully, and what steps to do. Well, you can do it in many ways, but this is my way to do it from minimal working condition up to a fully working machine. So first of all, you need a board and lots of passives. Always start with the passives. So first you want to know where to locate the stuff, and for that we have an excellent tool that I will show here, hopefully. Here, you go to I need to go to here and go to locator.reamiga.info. Here, have the locator and you choose a project, and in this case the ReAmiga 3000, not the TH version but the SMD version. And just go to a content locator. Here it is. Then we start with the caps, and I take a bunch of caps and I take the value I have, or I just do from top to bottom. So top to bottom, and you can see here we have two of them, and they are highlighted with red. So quite simple. And then what I usually do, I actually put solder on one side of every pad first. And I show you my new toy here, the microscope. Yay. But I mean now this is laggy as hell, so I will need to get a real capture card because I push it now and oh, laggy. Simply just put a blob on one side on every board. And oh, this is hard because I'm not used to this at all, and I have a bigger view in my microscope than on the camera. So by doing this I can put on components later without having to put more solder on it. Just put the component on one side, and when every component is in place, then I solder the next joint. So I, in short, will do that now. Maybe speed it up or just cut it out because it's quite boring to watch in a way. But I do not. I used to do this for the 1206 places, etc., not for the electrolytes and so on, just for the small passives. Anyway, now I have done that, and time to put on, and I chose the 1000 picofarad. We needed 2 of them, so I have my stash here with the caps, and they are actually all sorted in the same way that in the locator, so it's easy for me to find. Otherwise you spend half of the time building the machine searching for parts, and that sucks. Take out 2 of those fantastic caps. Put the rest in the bag because I have several kits. And put it in the location. Marked on the board as well, but it might be quite hard to read. And actually I do this quite fast. I just put it there and don't really focus that much on putting it nice, because I will reflow it later with hot air and flux. This is just to get it in place. And when I've done all components, and only after that, I put in the solder on the other pads. Oh, this is hard. I must watch here because I need to get a better capture device for this camera. Anyway, not much to watch at, so I just do this somewhat off the camera as well, because this takes time. So I do all the passives and not the electrolytes. So in the list you skip the 22 microfarad and 470, etc. You put them later. Just a small surface, the small 1206 components. And I also skip all transistors and diodes for the moment. Only the passives, and then I will be back when the passives are on the top side of the board. Okay, all resistors and ceramic cups are in place. Now it's time to do the ferrite beads. So let's go back to the browser again, and we go to ferrite beads, and we need 17 of them, as shown at the bottom. So back to this monitor, we have 17 of them here, and put them in place. I actually use this type of tools when I do this type of soldering. I'm not using a microscope because the field of view is quite bad. I should use glasses, but I refuse to accept that I'm old. So time to put them on. So ferrite beads are in place, and now the fuses. And back to the browser. And see here, the fuses are located in various. I think, yeah, fuse. And we need 5 of them. I noticed that I never switched from the locator to the camera, but well, I put down the small resistor, the small fuses with the number facing upwards and readable from this area. Not really needed, but that's what I did. And now it's time for me to put the solder points of the solder joints of the other points, and that's where I actually do it. Just do it from this, and you can also drag solder this. But I have the wrong tip. It takes too much time to change the tip because I don't have a solder station that can do hot swapping the tips. So yeah. And well, now everything is in place. It's not centered, it's just there, so you can rub it on so you don't knock off any component. And I haven't done any diodes or anything, just the pure real passives here. And now I will actually turn the board and do the same here. I put on all resistors and caps. And well, I will do that off camera. Just seem to watch it. So, okay, now I have put on all my resistors and caps and ferrite beads on the bottom side as well. Also solder the from both places. And now I will do something you don't really need to do it, but I always do it, is to reflow it with hot air and flux. And I use the Antec flux that I buy from Louis Rossmann, but you can get it from other places as well. Some fakes and some not. I bought some on eBay once and it looks the same, but it behaved different. Still quite good, but behaved different, and it was more or less just grease. But well, it kind of worked. It was cheap, and sometimes I buy it to use it for stuff like this because the quality of the flux is not that important during this part, but more important when you do surface mount like the 030 etc. later. I transfer it to this ring because I think it's more handy, and well, I will show you why I do it, and you maybe understand why. I move to my microscope. Here I had by purpose done the bad solder on those four caps. You can see that it's not proper there, and alignment is totally off. I put on some proper amount of flux here, and put on my hot air station. Like I use for this one, I actually use like 350 degrees or so. And blow it. And you will notice that when the heat is melting the solder, you will see some magic happens, and they will like dance into the right position without really having to do anything. See, I'm not touching anything, and they just move into the right position, and yeah, like that, magic. Sometimes I even poke with tweezers so they just move into place. But this is why I do the hot air afterwards, because well, you can see the bad solder joint was fixed, and the misaligned cap just got into place smoothly. So perfect. And so now I will just do that on all caps. But I'm not using the microscope for that one because it was just to show you. So I'll put some flux on, proper amount, if you know what that means. Board will get messy, yes. We'll clean it off later. Okay, I've done that, and flip the board and do the same on the top side without any diodes, etc. Because I don't think it's good to heat them up in the same way. Okay, that is done. Now it's actually, you can clean it off with isopropanol and actually even scrub it with water, etc. to get rid of the flux. If you do water, make sure it's dry first. You can use plain water as the signals are not that close and fast, etc. So well, the residue of water will not really do anything. Or you can just afterwards clean it up with isopropanol, something. I do it later, even if this will not fit in my ultrasonic cleaner, but I can do corner, and this middle part I have to do myself. Okay, now what? We have done all the small passives, and now we start doing through hole stuff. Resistor packs. I decided to keep the through hole resistor packs because actually they're quite convenient to solder anyway, even if it's quite many of them. And well, it works. There are two types of first we can do like this and show where it is. It's in various, and you have different here. On this locator I just updated it. There are the 120 ohms. I removed them. If you have them, you don't need to populate them at all. It's not populated on the original board either, so this was taken from the schematics and yeah, removed later. So if you have the 120 ohm ones, do something fun with them, but not on the board. And also, when doing this, I will not populate the 220 to 330 ones. They are for the scarcity termination. We do them later. Do not populate them at this moment. And there are two types. There are bust and isolated. The bust ones is actually on the 10-pin ones. Okay, there are actually 9 resistors connected to pin 1. The isolated one are actually 5 resistors independent of each other. So the bust ones must be in the right, correct polarity, and put so they are here, and I will move stuff around my table here so we can have a discussion about that. And for that we need a microscope, and I move it around to where it is. Okay, the field of view in the camera is not that good, but much better for me here. But it's just to show. Here is a resistor, and I can't do less zooming. You can see there is a square here, and also on the resistor pack there are a dot. The dot goes to the square. Simple. The isolated ones have also, some of them have a dot. They can't go in any direction. There are some places on the board where I have actually done a square on the isolated ones. That should be removed. You can ignore them on the isolated mode. But here must be, as you can see here, maybe, yeah, it must be, this is so hard. The bus mode must be with a round marking to the square on the PCB. It's really important. So now I roll off the microscope, and what I actually do is that I can show that on the microscope as well, actually. I take my blade tip, and I actually, when I do this, I from the top side tack one pin in, Then I heat up a line so it's straight up. And that's what I do on all resistor packs. I don't solder them on, just one pin. And then I flip the board and solder in on from the board, and then they are quite steady there. They are not loose, anything, they will be there. I will do this now and see how many I need. I need 13 of them. Put one there. Okay, so now I've placed all resistor packs, detecting one pin only. Now comes the fun part of soldering them on the other side that I'm doing with drag soldering. Flip the board, and the fun thing is where to find the components. I actually just sweep board and feel that, yeah, here it is, and then I do it. Let's see if I can do this. Show how to drag solder in a microscope, but I don't know how good it will be look like. But yeah, here's some pins. You can actually, for better result, add some flux, and then use this knife blade. So, and what I'm doing is actually just put there and make sure you heat up all pins. And as this is surface mount, you must wait for more. Not surface mount, I mean through hole. There's a lot more heat that needs to be transferred to the via. So actually you can raise the temperature of the soldering iron and it will be good. And I will do this now, like this. I use my, instead of glasses, actually I don't care about doing with the flux right now. The flux in the solder wire is quite okay for this. Usually I'd start at the middle of the resistor pack, as I'm not sure what pin I detect. That's a being upside down. So start from middle instead. Then you will not heat up the only pin with solder, and the resistor pack will just drop under the board. Okay, I think I've done them all. Just feel on the top side, and if I have missed one, it should be somewhat more loose, but you never know. You will notice that later when you're doing the rest of the soldering. Okay, now the three special ones, the 220, 330 ones. They are made for stress determination. Sometimes you want to remove them, so that's why you don't solder them on. Put on the strip like this, and do it as a socket. For doing that, you can remove them if you need to, depending on your SCSI configuration, internal, external, etc. As you all know, SCSI is magic. Actually, it's not that advanced. First and last unit in the chain needs to be terminated. And nothing more about that. And the controller on the board is in the middle of the chain. So if you want to have something on external, you remove those. And this one have bent pins, so I'll maybe just skip it now and put on the socket anyway, and just be happy with that. Yeah, do that later. Not really needed right now, just to have the correct length, like that, and put them in. They are buzzed, so the correct one. And here it's, I can't really, maybe I can come in and do the same here as tacking in. Yeah, works. Good enough, anyway. Also put in solder first and then heat up and put in the socket there. Yeah, right. Turn it over and solder socket in place. Okay. Now technically all resistor packs are and passives are there, except my stubborn little here that doesn't want to go. See if I can pins are all the way here, so if I don't get in here now, I just skip it and put it. Perfect. Okay, next step is some diodes, etc. And now I can find that where I put my stuff in this. Okay. Next step is can do the tantal cap. Tantalum. I'm a fan of them. Some of you might even put on some tantal caps where the electrolytes are, and even ceramics. Do that, and I will not support you. Simply, I will not support you. Independent of the issue, I will not support you. You should use what the designer have used. They behave different. There are reasons why they are different. So if they are designed different, put it there. If you decide to change the design but use another component, then you're on your own. Simple. Anyway, the temporal one. This one is, you need to do this right. And that's why I'm showing you, hopefully. And those are somewhat different. Take a note at the positive part here. I'm going to put a soldering here. And to differ to electrolytes, the positive part is actually marked here and not the negative one that are usually. So do not put this wrong, or this one will blow. That blow. And that's why one reason why I don't like the tantodes. But now it's there. And then we do we can go to the locator again. Check here where we can do transistors, the NPF 102 or the YJACs. Put them on. They're going to the audio port. So nah, that's the wrong one. I can do like this instead. Yeah. Oh, this is. I see on this video camera here you can only see 25% of what I can see, so it's somewhat hard, and with that like 1 second extreme delay, it's hard to align the microscope correct. I will get HDMI grabber instead, as doing HDMI from this camera is instant and real time. This is for sure not. So I put solder on each pad there. And this is annoying part, is flipping the component, right? So and then we can take resistors here. We can the NPN one is located close to the serial port. Go like this maybe, and see if the other one. Okay, the PMP ones are, if I remember correctly, located at the audio port. Well, one of them is that one that turns on and off the audio filter, and the other one at the bottom of this card is actually for the optional LED, so you can actually skip that one if you do not fancy onboard flicky blinking flashing things. I like it. Solder on the tip. Usually I don't solder these type of components on the microscope, but well, I have it here for recording purposes, so why not do it as well. This is far out of my room, and maybe the scope will cover me. This is purely optional. You don't need to have this one here. I like it. I can tell you that I'm not watching on the monitor on soldering this because the lag would be totally impossible. Okay, that's it. While we are here in this area, let's do the LEDs. The color of the LEDs are not important at all, but I will use a yellow one here for the 5 volt. I can use a green one as well, but the green ones I have are so damn bright. Okay. First of all, location. Here on the board you can see a small triangle. On the bottom side of the LED you can see a triangle as well. That's how it goes. Okay. And some of them also have this tiny mark. Not all of them. So, yellow there. I take a red one for the LED. That's when the CIA put the LED on high, so you can see it. I should take the finger, put flux on my tips, my tweezers, and then stuff just gets too damn sticky. This is the LED signal onto the board there. They are connected, so you can see that when it turns on, that the power goes from half bright to full bright. But I want to have it separate here. On the TH version, you have just two LEDs. That's the power one and the SCSI one, and nothing different there. And then I take the hard drive one, and actually this one I take blue. The blue LED is really bright, but when loading from SCSI, etc. I kind of like it to have bright, so why not? Like that. Oh, lots of solder on my tip. Okay, that's all in place. And now I will soon put on the power connector. Here's my mouse. But first, as you can see, they are quite close to the power connector. Two of the 47 microfarad caps. So actually, I put them on now. Usually, I put on the electrolytes after it's done and tested. But as those are so close, I prefer to do it now, so I don't burn the connector for some reason. Put there. Interesting thing is I get a lot more stable in my hands when I'm watching in the microscope compared to not. Oh. Okay. Got those electrolytes on, and then the cake power connector. And that one actually is quite easy here. You can't turn it wrong. You can just hold only in one way because there are a pin here. So you can't turn it wrong on the 4000, etc. You can press it wrong. This is better because, well, sure, there are maybe solder it, but then as Apple said, you're holding it wrong. Okay. Put on one pin here, lots of them. I push down the card so I can feel that it is in center, and don't do that what I just did, that after heating up you remove the board directly. It's still hot, solder isn't not hot yet. Check that it's aligned and then put it on. And here I want to say be quite generous, as this will take a lot of stress when you remove the power connector, etc. So make sure it's really fastened, and the middle ones here are ground, so they will be somewhat harder. like that. And of course I did skip some parts, so I will do that now. And that's the diodes. Chrome again here. And you go to diodes. Here we have 4 of them. And they are round. They roll off the table and that's right. Annoying bitches. So do that. No, I am doing this. Of course, I will do it on microscope. Check the table here, and so I can get a better view. And here we have 1 on them. Oh, wrong way. Okay, this is the location for one of the diodes. And as usual, I put solder on one tab. And then take a diode, and same here, orientation. You can see the line here. So you locate the diode like this. You need to place all of them, because otherwise you will not have correct power to the board. So there are some protection and some, well, making sure stuff is correct. So all diodes must be in location. I have no idea if it's my camera or the camera connecting to the microscope is a reason why I don't have the same view. Or well, this is the camera is mono and the scope is stereo. Maybe that is for sure one of the reasons. I will not do any Lewis Rossmann tutorials anyway, so the camera was built in with the price. Okay. those diodes, and then we have different diodes. This happens sometimes for me. Annoying. That's for the real-time clock. Diodes are there not for protect charging, because that stuff is removed anyway. What is there just so the power doesn't go to the wrong place. And they are smaller ones. Let's see, this is the first time I've ordered this one, so I maybe had the wrong type. Wouldn't that be fun? While I'm doing this, I actually forgot to swap out the screen from the Chrome view to my microscope. These are the two diodes for the real-time clock, and take a notice of this stripe here, and the stripe is on the PCB as well for that correct location. Anyway, back to basics. Now we do another thing that is new on this board and not available on the TH1, and that's a replacement part for the low reset circuit that we can see here. And so if you are doing the TH1, you need to take the component there from the board, from the old 3000 board. But if you're doing the TH1, you can either take that component, or you can do from the BOM that I delivered with them, take low modern part, a low voltage detector instead. And that's what I will do now. So I will move this one here. So okay. So with this component here, you do not put component in the U112 location here. Camera, come on. Yeah, you do not put the notes that the board PCB says OR. Okay, what we've done? Yep, we have solder or passives on, and so on, and we are putting all diodes on. That means we should have power and signals, everything correct to the board. So I'm putting power connector, power on, and we should have yay, we have light. Not that impressive, right? But yeah, 5 volts to the board. And that's it. Now we actually start to do the real stuff. But first I will do a cut here so I can do some preparations before this. But next step is to actually start building this up. This is now when the fun starts, instead of the boring passive part that just takes time and nothing happens, and yeah. So time to start doing the interesting things. First we need the 28 MHz oscillator. and I usually want this heavy socket. And if you look here, you can take one of those and solder them in there. And this is a slightly built-in socket. Just cut off the excessive part there on the other side later, and it will work fine. But drawback with this is that the pins on the oscillator needs to be quite long. So if you remove this from the card, then it will be much harder. So instead, you just take a normal socket, players here, and push it up. This can be hard, especially if you want to do it like this, and remove the extra pins you don't need. For the 28 MHz one, you remove everyone except the edges. For the 50 MHz one, you leave also the middle part pin, the middle pin here, there, because it supports both types of oscillators. Again, the thing that you need to do, you can put it without socket, or you can support only one type, but if you're fiddling with the overclocking, etc., then it's always great to have options. Same with the external FPU oscillator as well. I really generally doesn't like sockets. They are an option to have more issues, but some like them. But for this, I want to have, at least for some components, like the ordinary socket ones in the 3000 and the oscillators. So let's put it there. Move away this. Then the pins on. So here, there. Put solder on one pin. Push it up with the finger. Do not touch the pad you are actually soldering, because then you will say some words because you burn yourself. Okay, we have done that. Put it there, and I can actually take some hair oscillator there, and that we can power on. See there, and there are some that I never can find. There we have some pads are not hidden. Now there are some vias is not hidden. They are test points. And now with this professional setup, remember that I don't have a ground pin connected to this oscilloscope, so signal will be somewhat bad, etc. But you can see here 28 meters, no ground. Then yeah, I see there is a signal. It's bad because yeah, no ground wire, fully normal and okay for this kind of setup I'm doing right now. Turn off power again, so I don't fuck up stuff. And then we need to put in components so we can have 15 kHz, 16 kHz VGA signal, so we know as parts are working. So first, sockets for Agnes. Oh, I hate throw-hole stuff. I really do. Even if sockets like this are actually more sturdy than the SMD ones, but yeah. In one corner each, push it up so it's well aligned to the PCB, and drag solder. And well, Agnes is there. Now we need Gary. Okay, that's it. We now have Gary socket and Agnes socket. Put in that Gary and the Agnes. Hard to get, impossible to get Agnes. Like that. Some power. Actually, should solder in an RGB connector here, not the VGA one, because this will not work yet because we don't have any amber, etc. But the RGB connector to see if we have a sync on screen, but actually I don't have any connector now, so I will use my oscilloscope. Power on, and we don't get sync because I'm stupid. I need to put in the components for the reset as well. And do a shortcut here because I have to find the components. And well, again, then we put the 74F32 in place here. And as usual, I'm doing my half surface mounting, so I'm taking one pin and the 7407 doesn't need to be F actually. And turn it over through home magic. You feed the board all the time. The reason I didn't do every component as surface mount is actually because sprint layout that I'm using is horrible to edit stuff, so edit this to surface mount will take forever. How did the just for one, but I heated up pin 1, that one I tacked, so it's dropped out of the board. Like that. Now let's see. Here, power, that one, and let's see. Yes, we have something here. My oscilloscope there. You can see a 15 kHz signal there, and there we have Oh, my professional stand here. Okay, auto. I'm lazy. And we will have a 50 hertz signal. So in basic we have a sync. If we have connected a monitor through focus, monitor through the port there, but that will have solder on for the next part. That way we would have the sync. So this is a minimum setup for to have a sync. You need to have the, well, all passives always, because yeah, could clip someone, but first of all passives on. Then 28 megahertz signal. You need it to get the 28 megahertz signal. That's the Agnes needs. Actually, it goes via the Agari. It's somewhat cleaned up. Go to the Agnes. Agnes creates the vertical and horizontal sync, but you need those two to handle reset, so the Agnes doesn't go into reset all the time, and that's also not producing the signal. Sometimes it can actually do that without those two because of the floating signal, but skip that, put in them on, and will work every time. So minimum setup for VJ sync. This is a start. Next step, or next part of this series, will be how to get the CPU working and output data from this serial port and try to detect the shipment. That's the next part, but this is the end of this part. Hope you like it.